Okay, in example 2, we're asked to use the tangent of x equals 2 and the fact that the sine of x is less than 0 to find all 6 trig functions, and we're only given one of them. So whenever you have just one of the trig functions and you need to find the others, the easiest way about that is to use the Pythagorean identity. So we're going to look at our hexagon, and remember we make triangles for Pythagorean identities. So I start at tangent of x because that's the one that I know, and then I'm going to head to the center and then down to make this triangle. Right? So that Pythagorean identity from my hexagon tells me that the tangent squared of x plus then my center is a 1 squared, which is 1, is equal to, and then I follow that down to the corner to make the triangle, and that's secant squared of x. So if I substitute what I know, which is that tangent of x is equal to 2, then that's going to get squared plus 1 is equal to secant squared x. And 2 squared is 4, plus 1 is 5. So the secant squared of x is equal to 5. Then to undo a square, we square root both sides, and we'll get a plus or minus square root of 5 as the exact value of the secant of x. Now, how do we know whether it's the positive or the negative with the square root of 5? And that we have to figure out what quadrant it's in to know. So if we remember the acronym, all students take calculus, and the tangent was a positive 2, so we need to be in either quadrant 1 or 3 because that's where tangent is positive. But we also know that the sign has to be negative, and the A means that everything, all of them, are positive in quadrant 1, so that leaves us with quadrant 3 as the location of our angle x. And in quadrant 3, tangent and cotangent are positive, but everything else is negative. So that means that the secant would have to be negative, and therefore the secant of x is negative square root of 5. So we'll go ahead and put that result on the hexagon. Secant of x is negative square root of 5. The tangent of x we were given, that was a positive 2. And now we can use our reciprocal identity to get the cotangent. So the reciprocal of 2 would be 1/2. And then to get the reciprocal of secant, which is cosine, we would need to take the reciprocal of negative 1 or negative square root of 5, which would be negative 1 over the square root of 5. And then we're going to rationalize that denominator by multiplying by square root of 5 over square root of 5. And we'll get negative square root of 5 over 5. And that's our cosine. Negative square root of 5 over 5. Okay? So we've got 4 of the 6 now. In order to find the sine, right, we could use the product identity if we wanted to. So that would be the cosine times the tangent. So cosine of x times tangent of x is equal to the sine of x. So we would take our cosine, which is negative square root of 5 over 5, times the tangent, which is 2, and that would give us a negative 2 square root of 5 over 5 for the sine, which does not reduce further. And then we could get the cosecant by doing the reciprocal, but since that's such a nasty looking fraction, I think it might actually be easier to just do that product identity again. So we would have cotangent of x times secant of x equal to the cosecant of x. So we would multiply 1/2 times negative square root of 5, and we'd have negative square root of 5 over 2. Yep. And if you hadn't wanted to use the product identity, you could also have done a quotient identity, right? The tangent or I'm sorry, the cosecant would be the secant divided by the tangent, right? See how you'd also get that negative square root of 5 over 2? Or the cosecant is the cotangent divided by cosine. You could have gone that way. So lots of options with these identities. You just want to keep trying them until you get all 6 of your functions evaluated.